Hello folks, as I present the first video, I present the second video right now about the unification of physics. Empedocles, a Greek philosopher, always was searching an equation of love because he believed that nature was made by atoms, and these atoms take action by two feelings, hate and love, that approach the atoms or give distance from them. And these equations you only now present after more than 2,000 years of research. Or that means the dream of Einstein that have the searching for a long time during his life, and for this unique equation that unify all physics. All right, I present to you now this equation that is unique for all physics. Let's go to see a recapitulation first from the first video. In little words, the general theory of absolute, as I call it, established that the momentum of universe is constant. And equals to 0. The second conclusion is that any component of any physical system of matter is linear and or angular momentum. A part of a whole, okay? And the third conclusion is that the universe is Newtonian, and it's valid for all forces of the universe, the three laws of Newton. Force is equal to variation of moment in time. Well, this gives me a generic approach and conclusions from the last video. Now I will show you the unique force for all universe. And first of all, we will construct a model like an atom. Imagine that we have here an atom or the Earth planet, and here the sun or the nucleus of the atom. Then this electron have a velocity v, tangential velocity, and a force a centripetal force F that maintain the electron or the Earth around the Sun or the nucleus. And here, this mass of the Earth or the electron has a mass m line. Let's call m line. And here you have, let's go to imagine, because according to our last equation, the differential equations differential law that I presented in the first video, you have particles, and that the particles are infinitesimal. In these particles, they are the molecule atoms, because this is indivisible. You can divide it as many you can or you want. Then, if you have this atom, imagine that this little atom, material point of matter, is being choking against the Earth and the electron to maintain itself on orbit around the Sun or around the nucleus. All right? Then let's go to imagine a little portion of variation of mass dm dt on the direction of acceleration of the Sun or the mass. And let's go to consider this as a cause for this field. Let's go to see what we can achieve. And this mass around this region, let's go to call M. Okay? Let's use our construction that will show, and let's go to see what we can achieve if we consider M equals M line plus dm dt. Right? Let's consider this hypothesis and apply to the law of Newton, the second law of Newton. Let's go to make the calculus using this hypothesis, right? First of all, we'll consider force equals dp dt vector E, as P equals to mv, a momentum of the bodies. And if you make the derivative of P, we can achieve this new formula, mv under time equals, from the chain rule of derivation, we have variation of mass under velocity plus the variation, the acceleration and mass. We achieve by the chain rule this formula derivating mv, the momentum, right? This is so simple, is a simple calculus of a derivative. Then let's go to derivate m equals m line plus dm dt. If you can see that if you derivate this, and I show all expressions here in transformations, and perhaps it take time, but we need to see what it take us. let's go to make the calculus here. You are derivating the expression, right? putting velocity and common. We can cancel these both terms. And to give to me this equation, final equation. Well, this is what happened if we use the configuration of the initial system like we established m equals m line plus a certain variation of mass on the system. Well, analyzing these dates, we can see that dm dt makes the paper of, here is the force, the paper of gravitational field and the electrical field respectively to the Earth around the Sun and the electron around the nucleus, atomic nucleus. Then the result is the well-known train roll, where the constant term, that one, annul itself, is null. Analyzing in physical terms, there is a variation of mass in the field that is responsible for the variation of velocity dv dt, vectorial velocity. Both the terms are in equilibrium because the forces respectively to atom and the gravitational force exerted by the Earth by the Sun are constant. Well, this is an amazing thing because from this equation we can generalize this equation for all universe. That's the unique equation for all universe. That one, we can generalize this equation for all universe. And we have a total and global stability from the universe from this particular law that is valid under all universe. This is the law. That's the unique equation. We can write that equation like that. Force equals to 0. Because the force in the universe comes in couple. And we can make a summation of this particle, something like that. That's the unique solution that Einstein was trying to solve. I don't know the motives because he didn't achieve this goal. But it's so simple like that. Plus the second term. The first term is the Newtonian term, mass multiplied by acceleration, like in the second law of Newton, Isaac Newton. And the other term is the correction from the relativity, or it means that the term is the correction of the movement that makes me the field. When n goes to infinite, this equation goes to 0. This term is mass under acceleration. This is Newtonian term. But this another is a correction from the relativity. And we have the relativity under a case of Newtonian case. This equation is a stability equation of Newtonian stability. And this equation is completely Newtonian. I don't use tensorial algebra to explain the universe. This equation is simple like that. And this equation explains everything on the universe. This is the only equation from all the universe. Or it means I have force equals mass versus acceleration plus the construction of a correction of generalized term and the relativity include. And the force is equal to 0 because the forces comes in couple in the universe. Or it means that's the unique equation for entirely universe. For all universe. That's better. For all physics. All physics is under the role of this unique equation. This equation is unique for all phenomena of physics. This is the equation that Empedocles was searching 2,000 years ago. But he cannot choose this because probably he didn't have mathematical constructions to do this, all right? Then we conclude that these searches are not in vain, okay? That's the equation. And this equation, generalized equation, you can apply to any isolated system to determine the system. It's applicable to any arbitrary region or dominion where exists forces. And here you can summation the forces 2 equals to infinite forces in a space, in a three-dimensional space. Or it is valid to any dominion of air n. Any dominion, any dimensional space. This is valid in any dimensions. And this equation is valid for all universe, any circumstances, any problem you have. Don't mind what it is mean, okay? Well, let's go now to see what to do with this equation. Because it's only not an equation, you have applicability to this equation. You can apply this to the entire universe to make some calculus and ever dominion of engineer and something like that, right? Let's go to see some applications for this equation because it works. The infinite is on this equation, all right? Let's go how to make a calculus of orbits applying this equation. Absolute orbits, all right? If we substitute F equals to mass and a derivative second, meaning the acceleration, where u is vectorially x, y, z, x, y, z, x, y, z. If you can substitute this on the place of the force, that one force, we have a spectacular result. Let's go to make this account to see what I can say to you. If I have a mass and a mass that is constant, all right? Let's go to consider a constant mass, like the Earth around the Sun. And this acceleration in time. And you have the mass of the field, because you can make a calculus with the field. And this can you determine the black matter, okay? The dark matter of the universe. The mass of the field under derivative second under time plus a mass. Let's go to apply in the formula, right? Because here you have a decomposition of a mass that is the field plus the constant. And you can apply something like that. The field, and here the constant mass if you determine this equation, because first equation to achieve this one thing, you need to apply the force like and you need to apply this another equation. That means a first step before this one thing. Here you have the mass. You have the mass of field plus constant under the acceleration plus applying that equation. All right? If you apply that equation to the gravitational field, we'll have that one. We'll have that one. If you have a mass constant and the field plus the constant plus the field, we have that equation. Let's go to solve this equation that can be expressed by another development. And we have the mass of the field plus this thing on the field equals to 0. Then rewrite this equation. You have the mass of the field that multiply the acceleration plus the velocity equals to 0. Well, with this in mind, we can transform this one thing, because if it's 0, this term is equal to 0. As this term is equal to 0, we can rewrite this thing something like that. This equation can be rewritten something like that. This acceleration, this variation of velocity, right? And acceleration, velocity equals to 0. Then we can compute this something like that. This gives me the equation of Galileo Galilei. They all know formula from Galileo. This is Galileo Galilei. Well, and this proves that the general theory of relativity is a nonlinear case of Newton. And the theory of Newton is a nonlinear case of the equation of movement of Galileo. You can prove from this equation. This is marvelous. Then we go to see application from this equation, all right? An application to this equation: suppose that a planet and a hypothetical circular orbiter radio are around some star here, and here the planet. We can calculate and to demonstrate that it works, right? Let's go to make the calculus then. If F is equal to gravitational force Gm m under, this is Newtonian law from gravitational force, all right? And let's go to substitute this force F that results the equation G m equals mass from constant and field. Okay, let's consider this mass constant plus velocity. Then this is a new method to solve the problem. Let's go to substitute this on the equations and let's see what it takes. We can consider better an example is something like that, because the equation is unique for all universe. If we compute a planet, you can compute per 2 electrons in an hydrogen atom, and it only change the equation of force. That means the charge of electron, only the substitution. Well, let's go to make for a hydrogen atom. Let's go to make the calculus instead of a planet and see what it is result. Substituting the force on the equation, mass of electron plus the field acceleration of the electron variation in the field equals to the mass of the electron, velocity of the electron, plus that gives to me let's go to take this calculus. And you can see that the method here really functions to calculate any problem I want in physics. Or it means that if I isolate the mass responsible for the field, here I will have the quantity of dark matter that is aging on the system, or it means that dm dt, if I solve the problem, I isolate the dark matter. You have a large expression is this large expression here. Well, second step is substitute this same equation that I have compute here and substitute this equation on the first one, or it happens something like that. The acceleration, let's consider two-dimensional problem, x, y. We have the mass of electron plus dm dt, that's that equation. We can substitute here. It's a new method of calculus. That's a discovery, okay? It's an unknown method that I'm revealing here. Well, I substitute in this equation the value of dm dt here. That's we compute in the substitution, first substitution, okay? Let's go to see what this calculus will lead to us, and we are going to have a large expressions. Let's go, I put here only to see. And let's go to C. Mass of electron plus the substitution then of the MDT. C is considered here. It's not C. It's electron here. Okay, here's our electron. The variation of electron. And the acceleration. Plus the same expression let's go to develop this equation, but this second term pass to the left side. And here we have only to change the sign. Here is equal, here is minus, minus, and complete here. We have this equation. Equals here to that one term. And if you develop this equation, we will put in these two terms in evidence together, and we achieve another formula. Equals That's the new formula. We can cut this mass, and we can achieve and cut to these two expressions that are equal. There's one thing with this one thing, and this gives me this term plus this term. Let's go to write and see what this means. It gives me this expression equals to that one expression, and this is marvelous. If we verify the limits of integration of this expression, we conclude that the orbit of the electron is a circle. This gives me, if someone knows complex variables, this is a circle. That's correct. It functions. And it proves that this is a new method to calculate anything I want on the universe. Since I have some, and I have this unified theory is a Newtonian relativity, because I don't need to use the tensorial calculus. If the force is constant in time, you can calculate the orbit, but it's not the existing possibility of calculus. Because if we don't know the distance in function of the MDT. But if you know some way, it's possible to know the orbit trajectory of these two bodies, right? And it's proved definitively that the problem of Einstein that said that God don't play with dice was correct, or it means that Einstein was correct and affirmed that the universe follows a destiny totally determined by the conditions of the problem in the initial problem condition. And we stop here, and it will follow in the third video the creation and destruction of the algebraic morphism of bodies on the universe, applying the theory, and it's so more beautiful than that. Thank you very much, sir.